Hello, it viewers. I am in Scale Conference 2026 in Mumbai. I have with myself a very unique guest.
Hello, my name is Rohit Kamath. I'm the Business Development Officer at UrjanovaC, a startup based out of IIT Bombay, founded by IIT professors, Professor Vikram Vishal and Professor Arnab Datta.
Okay. So, what do you actually do? Like, what are you trying to bring into the market?
Okay, so as we all know today that the air is polluted and CO2 is one of the factors which is responsible for the pollution of air. So we have developed a technology which captures air in two ways. Firstly, from direct air, which is called as direct air capture or DAC, and second is from industrial flue gas, which is called point source. So what we basically do is that when this polluted air comes in, we capture it and we convert it into valuable end products like calcium carbonate.
Okay.
For this, we have developed a technology. We have developed a catalyst which is patented, and we have used aqueous-based solution for that. We use aqueous-based solution, basically industrial wastewater and seawater. So if I can explain you over this, assume that the industrial waste gas is coming from here, and when it comes in, we add the catalyst. This is the reactor in which there is a catalyst, and there is also grey water or industrial wastewater or seawater.
So you do not need distilled water or purified water or anything like that?
We can use any, but we can use also the grey water.
Let's just assume we do not want to spend more money filtering air, so filtering water, so to say. So it can work on just wastewater or like just normal
water also, as well as wastewater or seawater. So once it gets mixed here, what happens is that the carbon dioxide from the flue gas gets absorbed over in this, and in the end we convert it into calcium carbonate, which is pure precipitation of the same.
So the idea is you collect gas from the atmosphere, dump it into this liquid.
Yes.
This liquid reacts with it. It's not a physical force that you're applying. It's a chemical reaction.
It's a chemical reaction.
And because it's a catalyst, it's not consumed by it.
Yes.
It's helping it along, but it's not being consumed. And then you must regenerate it, right? Like after it has acted and absorbed the CO2, it must go through some sort of changes, right?
So what happens is that we then recirculate the same solution back into the reactor, wherein fresh the flue gases come in, and the process continues.
Yeah, but like how do you remove, like let's just say this is stage one, right? Okay. Stage one, I'm dumping CO2 into it. It's liquid, it's reacting. What is stage 2?
In the stage 2, it goes to another reactor wherein it reacts with calcium ions from the wastewater, as well as if you want to increase the purity, we add additional calcium ions externally, and then it gets precipitated in another unit.
So precipitated, for simple terms, is basically settles down. It's no longer stable enough as a salt. It like almost dissolves.
It comes out as a salt, which you can dry it, and then you can see it in the form of.
And in this process, you do not lose any catalyst. Catalyst remains the intact, right?
Catalyst, you have to change. If I can give an example, for one TPD plant, we can use around 10 kgs of catalyst, which can be recirculated 10,000 times.
Okay, so loss is negligible.
It's negligible, and the best part is that we don't require much energy as compared to traditional technologies which are amine based, which require heat. So this is, since it operates in aqueous solution, it reacts in room temperature, which gets recirculated, and also the scale which we use is very less.
Okay, so your special sauce is in the chemistry reaction that is done by the catalyst.
Right.
Everything else is like every Tom, Dick and Harry can have, like the liquid, the gas collection systems and circulation system and all that. But your special sauce is in the catalyst that I'm pretty sure you guys have patented, right?
Right.
Okay. Okay, talk about, I have done that. I have collected the carbon dioxide, I have precipitated. What then? Can you, do you have to use calcium based stuff? Do you have some other option? Because let's just say based on geography, they might have a good, very cheap calcium source or may not have that.
Right.
So what sort of wiggle room or like variable options do you have?
So as I mentioned that since we use wastewater has some amount of calcium in that. So it reacts with that. And
hold on, like when you're talking about wastewater, do you mean hardness of the water or do you mean the soap we utilize, like what do you mean? Like it already has calcium.
It can be grey water, which you use in the industry. It can be seawater as well. And it can also be the wastewater from the industry, which go after condensing and all, which you use the water. Sometimes you throw it off. So you can recirculate it back.
Okay, so let's just assume I'm using seawater. So would it utilize the sodium in it?
Not sodium per se. It reacts with the calcium ions which are present in that.
So almost all water have some calcium ions.
Yes.
Okay, so is calcium consumed? like the calcium that you're adding, the catalyst is circulating, right?
Right.
But you are adding calcium in order to get the purity
Right.
out of it. So does that mean that calcium is the consumable?
Yes. So that's what makes calcium carbonate.
So you give calcium and that is consumed, and
Yes.
then you get calcium carbonate.
Carbonate, right.
Okay, tell me, why would somebody want to do that? Like, is there a market for calcium carbonate, or like what's the reason why would anybody want to do that?
Okay. So firstly, the technologies which are there, they only capture CO2. The CCUS technologies, they capture and they store it or sequestrize it, like they put it in the earth. But here is the technology which we have developed, which converts it into a valuable product.
Okay.
Basically, if I can explain that CaCO3 based on purity, you can resell it to pharmaceutical industries or cosmetic industries. If I can give an example of cement industry, the raw material used in making cement itself is calcium carbonate. Okay. So when in the furnace, when the gases go out, when you convert that, you once again get calcium carbonate, which you can reuse it as a raw material.
Okay, then the first question people will ask, what is the like mass ratio? Like, let's just say if I'm getting 10 tons, 10 tons of CO2 sequestration per day,
Right.
how many tons or grams of calcium carbonate I'm going to get?
Okay. So for 1 TPD plant, if you use, add capture 1 TPD CO2, then you get around 2.25 tons of calcium carbonate.
Wait a minute, you're getting more calcium carbonate than carbon dioxide?
Yes. Yes.
Are you sure about that?
Yes. Yes.
Okay, that sounds complicated. Okay, so and again, this does not catch on fire, right? If I'm not
Right.
mistaken,
It's not sodium, so
yeah, it does not. Basically, it's stable enough.
it's stable enough.
And unless you actively try to release CO2 from it, you're good, you're safe, it's
Yes.
geologically safe.
Yes.
Can you bury it like somewhere, just like I want to remove it? Like, because again, there is a risk if you start to actually consume so much CO2 and produce so much, there will be a point where this becomes surplus. Right now, it's a
Right.
consumable item, but let's just say keep doing it because we burn so much fossil fuel.
Right.
I'm pretty sure we're going to reach a point where this becomes a. So can we like just put it somewhere in the mountain, underground? Like, is it stable enough on a what you call natural level, like as a chemistry level? Like, would it react with water? How does these things work?
So basically, since it depends on the purity, if it is 99% pure, you can sell it to pharmaceutical industries. So
No, no,
it is so it's consumable. And second point is India is importing calcium carbonate.
Okay.
So obviously we are calcium carbonate deficient. So yeah.
Okay, so for short duration, we do not have to worry about it. And again, it is naturally stable material, so it's inherently not like, okay, it barely holds on. It's like, it's going to be fine.
It's going to be fine.
It's going to be fine.
It's sustainable as well.
Okay. So have you deployed any plant?
Yeah. So as of now, we have reached TRL 6 level readiness, and we are making a plant for BPCL refineries of 15 TPD. And also with Hira Group, we are developing a plant of 5 TPD.
Okay. Okay, so what's a plan for your company coming forward?
Yeah, we are looking for opportunities elsewhere as well, because as you might have seen that in the latest budget, 20,000 crore something was allocated for this technology. And nowadays companies are aligning in terms of carbon capture and carbon credits. They're thinking in that terms, because carbon nowadays, CO2 nowadays is not just an environmental headache but also a business risk, because a lot of ESG and carbon credit compliances. So obviously India is moving forward in this direction, and we are trying to tap in as much as we can.
So economically, what do you think is the ROI of this sort of technology? If somebody does this to their plant, what kind of ROI they are looking for?
So it depends from industries to industry, and also from the output which they generate. All I can say is that the CCUS technologies which are existing, they only capture and store the carbon dioxide. But this is one where you are converting and improving the, increasing your revenue on a daily basis. So yeah, ROI depends from industry to industry and company.
But give a rough idea, like how many years? Like, is it in decades or is it in years?
No, you can't say decades. As and how you implement this technology, you start getting the fruits of that. And obviously, once you sell, and as I told that India is deficient of calcium carbonate, so you obviously find market to sell it, and depending on its purity, you can get the ROI of out.
Okay. So what you are expecting from the basically environment that we are in right now? Like, is there interest from the in this technology from the industry partners and all that?
Yeah, after like from yesterday in the event, most of them were impressed with this idea of converting the carbon dioxide into something, right? So because they had no idea that we are converting this into a valuable product. And now I can see that from people showing interest and wanting to know more, obviously they will reach out to us, and hopefully we are looking forward to connecting with them and improving in this.
So this was a presentation for Your company name?
UrjanovaC.
UrjanovaC. So as you can see, we are trying to handle the CO2 problem, and he has a very unique ability, which most importantly can generate profit. Everything else is meaningless if you are not money.
Yeah.
So generating profit is a very unique thing, and it's completely made in India.
It's completely made in India. It's researched at IIT. It is patented by our professors.
And what about the special sauce? All of those are made in India, right?
It's
Like
made in
you do not have to import some special material or anything like that.
Actually, it's made in India since it's researched at IIT.
Uh-huh.
And yeah, I forgot to tell one more thing, that this is sustainable. The materials which we use are non-hazardous.
Uh-huh.
It is environmentally friendly, and at the same time, you are using the old, the seawater and wastewater, which is sustainable, and it is not hazardous to the
Yeah,
environment.
the biggest unique thing that I notice is the fact that you can use seawater. We have more
Yes.
than enough of it that we don't have to worry about it. And again, anything that consumes fresh water is not a very practically sustainable
Correct.
situation. So,
So also, if you use fresh water, let's assume that there is no sea in your industry, near your industry. So if you use tap water or fresh water, you can recirculate it. There's no need of filling it once again.
okay, okay,
Right?
okay.
You're recirculating it. And the second best thing about us is that the setup is scalable and it is retrofitable.
Uh,
As you can see behind you, this is a 1 ton per day plant. So you can see how much space it is taking.
okay. Okay, so what about the machineries that are required for this? Are those any special machinery, or they are normal market-based compressor, condenser and all that? Like, do you need special machinery, or machinery-wise it's just industrial parts?
It depends because it depends on what, as I mentioned earlier, the type of industry, the type of requirements they want, and the output which is coming out, the flue gas and the composition of flue gas.
Okay.
Based on that, we design. We have EPC partners as well. We have an expert team of process engineers and scientists who study that, and then based on that, we work on the
So it's
fabrication
more of a
part.
tailor-made product rather than
Yes.
like just order it from a catalog.
Right,
Like you have to
right.
spend some time to tweak it for maximum utilization.
Right, right.
Okay. So this is what it is. Anyway, it was very nice talking to you,
Same
and I
here.
really hope this technology grows. I would not like CO2 in my atmosphere. I would like it to be removed. So I hope you can do a very good job.
Yeah. Thank
So
you.
how can people reach you? Look into that. It's like how can people reach you?
So we are a startup based out of IIT Bombay. We have incubation from SIGN, which is Society of Innovation and Entrepreneurship at IIT Bombay. You can reach out to us. We have a LinkedIn page. You can reach out to us at UrjanovaC Private Limited.
Okay. So this was the presentation on this CO2 capture made in India, completely self-sustaining technology, and it can generate profit. So I hope you guys have liked it. Thanks for watching.
Thank you.